Optimizing with constraints. So what we've just been doing was we explored using constraints. Now let's talk about a really quick way I could have gone about doing this, and actually I do want to change this value here. I apologize. This area here is going to be 64. Okay? So, let's say we've given an area of 64 meters squared. We want to create a square out of this. Okay? Well, we know squares, when we're finding area, okay, is a base times height. But what's special about a square? They're all equal. So really, the base and the height can be represented as the same value, let's say. So if we have b squared is equal to a, you could say that. You could call both of them the base, right? Because it's the height and the base will be the same. In other words, in order to find the base, I can just move the squared to the other side. So I just need to find the square root of the area to find out my base. So what is this area here? 64. What is the square root of it? Then 8 will give us our optimal size. Okay? That's a fast way when we have an area. We just need to square root the value, and that'll give us equal sides on both. If we have perimeter, okay, let's think of perimeter of a square. Perimeter of a square, all the sides are what? They're all equal. So really we're just adding side plus side plus side plus side, which can also be written as 4s. Well, in order to find the side, I isolate s by dividing by 4. So all we need to do is take the perimeter, divide it by 4, and it'll tell us our side. So what's our perimeter in this case? 80. What's 80 divided by 4? 20. 20 will give us our square shape. Okay? So these will be shortcuts instead of writing out that very long process in order to find out how to create a square. Now what we're going to talk about, and let's say I've been given 40 meters squared as an area. What we're going to talk about now is only finding 3 sides. And what I mean by that is, let's say that you guys maybe own a building, right? If you're fencing something, you probably own a building on the property. So when I go to fence my area in, I actually only need to use 3 sides of fencing. So if we're only using 3 sides of fencing, our square is no longer going to be an optimal shape. Okay? Now we could go through the process again, but I'm going to help you out, guys, with a formula. Okay? Think of this as being the only length, and both of these being the width. Okay? So really, our perimeter in this case is going to be 2w plus L. That's going to be perimeter. We're only adding up 3 sides. We know that the area enclosed is going to be 40 meters squared. We have to figure out what is going to help us best here. And it turns out the best ratio, I'm going to just write the ratio here, will be if we multiply 2w should equal the length. Okay? So our length should be double of what our width is in this case. That's going to give us an optimal area. If we have 2w is equal to our length. Okay, so how can I solve this? Well, I can plug values in here using substitution way back in grade 9 stuff. How can I figure out our area in this case? So we have 40 meters squared. Okay. And we need to think of a width that will be half as long as the length that will get us to 40. So let's quickly maybe think of a couple of factors of 40. What are some factors of 40? 1 times 40, 2 times 20, whoops. 4 times 10. Anything else? 5 times 8. Anything else? No. Now, if we look at these ratios, I want you guys to focus on the ratio. None of these are perfect as a ratio, right? But which one's closest? Between our 5 and 8 and our 4 and 10 look really close. So we probably want to work with values that are going to be within that area there. Okay? So let's see, we try using both of those as them. Let's say that our width is 4. We'll call the small ones our width, and we'll call the longer ones our length. Okay. Let's talk about our perimeters here. These are all options for an area, and I'll move this over a little. Oh, that's not going to work. So we could set up a chart. If our width is 1 with perimeter, then our length is going to be 40, and we're going to have a perimeter of 42. If our width is 2, we'll have a length of 20, and we're going to have 24 as a perimeter. Okay? If our width is 4, we're going to end up with 20. Oh, wait. Yeah, that should be 10. Thank you. We should be ending up with 18 as our perimeter. If our width is 5 plus 8, we're ending up with 18 again. So, if you guys notice, because remember I told you about the ratio, these two ended up giving us the same answers. We got 18 meters for both. Okay, both those perimeters are the same. So what would be a value kind of in between that? What would be in between 4 and 5? 4.5. Let's try right in the middle there. Okay, so we're doing some estimation to figure this out. If we have 4.5 as a width and our area is 40, okay, so let's take that value. We know our our width is 4.5, and we know area is equal to length times width. Our area is constrained to only 40, so we have to find our L. We're going to divide 40 by 4.5, and that'll tell us what our length will need to be. So 40 divided by 4.5 is equal to L. 40 divided by 4.5. What happened there? I didn't write the right number, did I? 40. Oh, did I? Divided by 4.5. 8.8 repeated, it looks like. So a length of 8.8. Let's try putting that into perimeter. Perimeter was equal to 2 times 4.5 plus 8.8. We'll use our calculator for this. 4.5 times 2 plus 8.8 repeated. 17.8. So that is an amount that is smaller than 18. Okay? And what our goal was we were trying to find something that had that magic ratio of the width being half of the length. So keep that in mind when we have an enclosed area with only 3 sides.